Hi, I'm Kian. In this video, I'm going to show you a quick example of partial differential equations with mixed partial derivatives. So we have this equation here. We have the second partial derivative. We have a mixed partial derivative, which we've taken, first of all, the partial derivative with respect to y of the function f, and then we've taken the partial derivative with respect to x of the results. And we've gotten this function cosine of 2y times x squared. So we're going to work from outside to inside. So first of all, I'm going to integrate both sides with respect to y. So I'm going to integrate this. So I'm going to have a dy here, and similarly integrate this with respect to dy. The most important thing in partial differential equations is to notice that any variable that doesn't depend on the ones that you're integrating is basically constant. So for example, on the left-hand side, it's pretty easy. So we're just going to write as partial derivative. The y just vanishes because you're taking an integral, and integral is the inverse of taking the derivative. So we get the partial derivative of f with respect to x, and then this is equal to, now, we have cosine of 2y times x squared. Now, cosine of 2y is a function that depends on y, so that's what we're integrating. But x squared, sometimes people might think that we're also integrating x squared. But x squared is simply constant because there's no relationship between x and y. So we're going to kind of omit that and just kind of have that in our final answer. So if we take the integral, if we use a u substitution, u is equal to 2y, we get 1/2, and then the integral of cosine of u is sine of u. So we get 1/2 sine of 2y, and you can actually check your answer by differentiating. If you differentiate using the chain rule, we get cosine of 2y. And then we have that x squared back here, since it's just a constant. Now we're going to do the next step, which is basically the last step, and we're going to integrate with respect to x. So we're going to have a dx here. We're going to integrate this with respect to x, so we have a dx here. And now the integral of partial derivative of respect to x is just f. And here we can see that now the constants are the 1/2 sine of 2y because we're integrating with respect to x. So that part is kind of omitted and it's just stayed the same. Integrating x squared, we get x cubed over 3. So if we combine it all in all, we get x cubed over 6 times sine of 2y. And I made a small mistake because, and I'm going to show you why, because we have to have another variable here. Since I'm going to explain why. So here, since we first take the integral with respect to y, instead of having a because there's no bounds of integration, so you're going to have a plus c. But in partial differential equation, there's no plus constant. The constant becomes the function that is in terms of the other variable. Since we took the integral with respect to y, we have to add a function, an arbitrary function of x. So we can call it just f of x. And then we have to take the integral with respect to x of this whole thing for our next step. And if we do, again, for the first part of the integral, 1/2 sine of 2y x squared, we get this. If we take the integral of f of x, this is just fundamental theorem of calculus, we get capital F of x, because that's the integral. And now we have to add a function of y, because basically we've taken the integral of a function of x, and we have to kind of add a constant, the plus c, but the plus c becomes a function of y. So I'm going to call it, for example, g of y. And that's our general solution for the differential equation. If you want to first check a derivative with respect to y, you check it. So this part, for example, becomes g prime of y. If we take a derivative with respect to y of f of x, it omits, it goes to 0. It becomes 0 because it all depends on x. And in this part, if we take it with respect to y, it becomes 2 cosine of 2y, which becomes x cubed over 3, and then cosine of y. And then if you do it again with respect to now x, then the g of y goes away, so we're just dependent on the x cubed over 3, and then if you take the derivative, we get x squared, and then we have the cosine of 2y there. So I hope you found this helpful. Thank you for watching, and bye.